area of a circle, the formula that we need to use is pi r squared. So if you remember with circumference, there's two versions, either pi times diameter or 2 pi r. But with the area of a circle, we typically always use the radius. You could probably find a version with diameter, but we'll just kind of stick to pi r squared. So find the area of a circle with a diameter of 8.5. Switch back to my pen. So all the way across is 9.5. So that means the radius is going to be 4.75. Cut that in half. So area is pi times 4.75 squared. So notice here, I'm squaring inches, so that's where I'm going to get my square unit. So pi 4.75 squared is 70.88. So square inches, or inches squared. So that's to fill in that circle, 70.88 square inches. Okay, now this one, how about the area of this one? I just want the shaded part. So here I have to use the strategy of find the bigger circle, find the smaller one, and then we'll subtract them. So the big circle area will be pi times, so if it's a 6.75 diameter all the way across, the radius is going to be 3.375. And then let's do the middle one while we're at it. 3.5 divided by 2, that'll be 1.75. So pi times 3.375 squared is 35.78. And then the inside one will be pi times 1.75 squared. That is 9.62 if I go to the hundredths. So then we'll have to subtract those. And I'm getting 26.16 inches squared. Now you could, if you kind of set that up right away without calculating each of the individual, you could definitely do pi 3.375 squared minus pi 1.75 squared. Do it all in one step. Should work out still. Okay, so that will get us just the shaded, that ring. Okay, here's one where I'm having to help set up a HVAC system. So this is saying that the contractors are going to use this WYE to branch off the main trunk line to get air to each room in a house. To equalize the pressure, the duct of the WYE should ideally have the same area as the other two outflow ducts combined. Okay, so we want the going in to have the same area as going out. Calculate the diameter for the duct that is to branch into the 6 and 10 inch ducts. Okay, so this one's gonna be a little more challenging. So let's first figure out the two areas. So this top one, so this will be pi times 5 squared. Diameter is 10, so radius will be 5. So pi times 5 squared is 78.54. Bottom one will be radius of 3, diameter 6, so radius will be 3. Pi times 3 squared is 28.27. Okay, so combined, adding these two. So the total area of the out, where it's coming out, is 106.81 square inches. Okay, so that's the area of the output. Now it's saying we need to figure out what diameter should the bigger one be flowing into. So I'm going to write out the formula. So because this one we have to use a little bit of algebra, because I don't know what the diameter is. So now I figured out that the area needs to be 106.81. That's what the area should be for where it's going to flow in. Pi is just a number, so all I'm left with is r squared. So I should be able to do a little algebra here and figure out what r is, which then I could figure out the diameter. So to get this r squared alone, first I'm going to divide by pi. Okay, so either use your pi button or do 3.14. And it should be pretty much right on 34. I'm getting 34.00000, and then there's some numbers after, but now opposite of squaring something is square root, remember? So that's how we can get rid of that squared. So square root of 34 is 5.83. So if the radius is 5.83, if we double that, diameter is 11.66 inches, you know, or it's gonna be about right around 11/16, maybe 11 and 11/16, if that diameter existed. You know, maybe we'd have to go up actually to 3/4 if it's, unless we can make it really precise. Okay, so that one was a little more challenging, but definitely doable with our algebra skills.